Yo. Okay. This is a random I keep flopping. This is a random video. Pun intended because this video is on random variables. Today I want to talk about the expectation of a geometric random variable, but from the recursive interpretation. So recall, so let's say x is geometric success parameter p. All right. And the way I'm going to define x is the number of total trials. So number of total trials for the experiment. Okay. So yeah, you got to review the geometric stuff, but maybe I'll talk about it in here. So now we could ask about what the expected value of x is, right? And then using the definition, we can say that this is just the sum of the products of all the outcomes times the corresponding probability of getting that outcome, right? So here we could say, yeah, overall x. So, okay. So, but there's a nicer way of viewing this recursively. And you can think about it like this, right? Using this in intuition. So you can think of the expected value, the same thing as the sum of the products of all the possible outcomes times the corresponding probabilities, right? So if you think of it like this, but in terms of termination, right? So I can think about it as there's only two cases, right? You can either one, terminate the experiment, or I mean the case the experiment terminates, or you don't terminate. Okay. And I said x is the total number of trials. So if you're terminating, that means that on that particular trial, you got your success or you got the heads. So that means that when you're counting the number of total trials, that particular trial is going to give you one, right? So that means the outcome for that is going to be one, right? Weighed by the probability of getting that particular trial, the success is going to be p, right? And then similarly to not terminate, that's just a complement, which is going to be 1 minus p. And you have to count the number of trials from not terminating. Well, from not terminating, you still have to count that current trial, the current Bernoulli trial, and then you have to compute recursively this thing again, right? So this is where the recursion comes in. So you have 1 plus expected value of x, okay? And you could think about that as the outcome. And then you add that, right? And now from here, this is just algebra. So this is my take two because I flopped on the algebra, but let me see if I don't flop this time. So expected value of x is equal to p plus, now, yeah, you're going to distribute that. So it's 1 minus p plus 1 minus p times the expected value of x. Okay. So from there, you're just going to combine the expected value of x and, yeah, solve for it. This is probably could have been easier if I just defined this as q like they typically do, but this is good practice and also shows my students, if they're interested, how all of this stuff is connected. But anyways, so let's do it. So I'm gonna combine the p, so this is gonna go away, so it's gonna be 1 minus p expected value of x. So let me move that to the right side. So this is gonna be expected value of x minus 1 minus p expected value of x. Okay, so yeah, is equal to 1. And now I'm gonna factor. So expected value of x, that's 1 minus p. This is equal to 1. And then let me just clean up the inside a little bit. This is just gonna be p, right? So then finally I can divide both sides by p, and you're gonna get expected value of x is equal to 1 over p, as expected, okay? No pun intended. But yeah, see you.